Hi, this is Brendan from SSW, and today I'm going to talk through some code samples on SSW SugarLearning. And really the intention here is to do a quick review of the current state of SugarLearning and what I find difficult to work with in SugarLearning. And it's a starting point for then in later videos I'll make some recommendations on how to improve the state of the SugarLearning code base. So what I'm going to talk about today is I'm going to talk about the old MVC edit item screen, because that's something I've worked on, and just looking at how that's implemented gives you a good idea of some of the problems I find across the code base. So what we're looking at here is the old MVC screen you get when you go to edit an item, and what we're going to do is walk through how this screen renders. So like any MVC page, what you expect to happen is you'd hit a controller. That controller would create some kind of view model and pass that model through to the Razor pages, and the Razors will render. So what we're going to look at is how SugarLearning goes about fetching this model to display in this screen. And as you can see, looking around, it's a fairly complex screen, but the model's fairly simple. We've got 1, 2, 3, 4, 5, 6, 7, maybe between 12 and 15 fields. So typically when I'm looking for something, the code for something like this, I look to see a view model containing those fields, the fields that we are going to be working with. So let's take a look at the code that actually makes this screen happen. Well, we start off as expected, and we have a controller. This is called itemController.cs, and it has a function called edit that returns an action result. And you can see we pass in an ID and an optional module ID and a user ID. And you can see what happens here is we've got this function called getViewModel with original name, which gives us a model. And if we hover over the model, we can see the model is of type edit item view model. And then down the bottom of this controller action method, we see we're returning a view, we're passing that model through to the view to render. So far so good. We've got some code here that builds a model. We've got a bit of code here that does some more stuff with the model, but it's fairly simple to read this action. We fetch a model and we return that model into the view. So far so good. So let's see what happens when we actually dig into how we get that model. So we've got this function here called getViewModel with original name, which is slightly weird naming there. I would have picked something like get model for editing, or just get editing model, or get view model. But we've got this sort of weirdly named thing, get view model with original name. And if we look at how that's implemented, we can see that we've got this other function here that gets a view model, and then we're setting an additional value on top. So let's take a look at this actual object we're working with, this edit item view model, and pretty nicely named. It means the view model we need for editing an item. But when we look at it, we see that actually it's built on another view model. So basically this edit item view model extends from item view model and adds one field on top, this original name. So straight away we see we're not getting one view model here, we're getting our view model broken up into a hierarchy chain of objects. And if we start digging beyond this edit item view model into item view model, here's where we start to see problems, because this item view model adds a bunch of fields, then that itself builds on top of something called item details. Now click on item details and I see a whole lot more going on here, and this then builds on top of item base, item, exposable. So when we go back to our original screen here, all the fields required to actually fulfill this piece of functionality are scattered across a whole hierarchy tree of model records. So that's becoming harder to use and harder to read. I'm not finding all my stuff in one place, I'm finding it scattered all over the application. Okay, so one thing you can do when you build your view models in this way, of course, is you can reuse common field sets across many different view models. But I think what you lose is some simplicity. You've got this quite complex structure now of classes with all the fields you need scattered across them. So you've traded up some reusability with a whole lot of complexity, and it's this complexity that's actually making this code base hard to work with. Let's look at the code now we have to write to actually start working with this complicated view model. Okay, so now we're back in the controller and we're digging further into the code that we use that actually fetches us these view models. And we see we've got a edit item view model here being returned by this function called get view model, and that's pushing in the type we want as a generic type. And if you follow this one down through, you see we've now got a generic get view model where with a type of T, where T is item view model. So that's the parent class of that edit item view model. And so what you can see here really is we've got this structure of classes where the edit item view model is at the top, but straight away from this point onwards we're only dealing with item view models, and in fact we don't get to apply the fields that are specific to this one until here. So even though we've got this complicated get view model here that takes in generic types, we're not using anything from that type until after we've loaded it and assigning here. So that's quite complicated, but what gets even worse is when we start digging down even further into the layers. So we've gone to get view model, and here's where we start first time. Remember, we're now three or four functions inside each other. So we've gone from get model with original name, get view model, get model with a generic, and finally we're seeing the next level of our system, item logic. So we've gone 4 method hops before we even start seeing our item logic class. And the item logic is the first example of the logic classes across this system. So I think what I'll do now is take a step back and take a look at the layers of this application. Okay, so when it comes to layers of this application, at first glance we've got a fairly good sort of easy to follow structure, because we've got a domain layer in the middle, and that contains, as per onion architecture, all our persistent entities. So for example, we've got an item class which can save traits to the database, so that looks fairly good. And then on top of that we've got a repository layer. So as per the repository pattern, repositories are in charge of saving and loading our items, and as expected we've got an item repository. So far so good. And then on top of that layer we've got one more layer, which is a business layer, and that contains some logic classes. So if I come into here, we've got an item logic class. So all the way through we can see we go from the item in the domain is the definition of the item object. Then we've got an item repository for getting that to and from the database. Item logic, which is all logic on top of that. And then at the very top level we've got our controllers. So at first glance we look like we've got a fairly well-defined set of layers for the application to work through. But let's take a look at those layers in more detail. Okay, we're back in the controller, and now we're looking at the piece of code that kind of glues the controller to the logic layer, and that's this line here where we say item logic.getItem, and we're passing in an item ID as well as some user details and a company ID. One thing to point out here that's confusing, when we ask for a get item here, we're using this tenant account.user ID and tenant account.company ID. So that's all hooked up to the tenant in the URL that we're specifying and the user that you're logged in as. But earlier on in the controller, if I go up to the edit item here, you saw we were passing in a user ID here as well. So that's quite confusing. We're passing a user ID into the edit, but we're not using that user ID later on. We're actually using the logged in user ID further down in the view model. So that's one example of some code that's not quite as clear as it could be. Let's get back to that logic layer. So here's our get item. So let's take a look at this interface. And interfaces are important because interfaces really define the methods and is the interface between various chunks of code. And if we look at this one now, the get item, all these get features. So we can get an item by company ID, or we can get an item by company ID, item ID, and user ID. But because we've got this complicated structure for our view models, remember our view model had an edit item control, edit version, then a item view model, and then that in turn had an item details view model. It means the actual get functions for this is a generic, and we have to at runtime specify the exact type of item we're doing. But because the implementation is also working on a generic, and the generic is cast to item details, it means that the implementation of this can't actually fill in the fields of whatever subtype of item details we've created. All it can do is give us a new object with those fields from item details level filled in, and then we still have to on top of that do more work. So we don't really gain much from having this complexity with these generic types. So the next thing I'm going to do is actually go across to the actual implementation of this item logic. Okay, so we've now moved forward, and we're now looking at the implementation of our get item function inside item logic. And here's now where we're actually integrating with a repository layer, because here is loading a item, and that is of type item, our domain object, from the repository layer. So we're loading a complete item from the repository layer. Then we're calling this function to process that into a view model. So straight away we're not using any of the entity framework capabilities of selecting from the database directly into view models, which is what I generally do. What we're doing is we're loading the entire thing using a repository. So we're going to load an entire item object, and then we're going to manually work through to create a view model. And as you can see, because of this weird type system we've got in our view models, we're having to pass through the type of the item we're looking for, whether it's item view model or edit item view model, and we're having to pass that generic type all the way through to this create view model object, create view model function, and that runs through to another create view model, and finally here is where that type is being created. So if I'm doing the edit item view model, I'm now creating an item of that type here. But once again, all these fields that we're loading in this view model state, so actually what we're doing is we're copying from the entity item into the model, even though we've got the generics and we're loading, this can be of many different types, because this code here can only act on that lowest common denominator. We're only free to move fields that are of type in that item details type. So it's only after we return from these functions that we're able to use the fields from the type we've asked for anyway. So we've added all this complexity with generics and type conversion, but we're still not using it. It's much easier to have separate view models or functions that operate on subsets of these fields, rather than what we've got, which is this overcomplicated way of loading this view model and then code right back on the top of the control level that sets the one extra field we need for edit one, which is this item view name. So we've got this very complicated logic layer, a complicated logic layer that can give us objects of different types, but different types all with the same field set. Then once we get an object of that type back by specifically asking for it by name, in which case we've asked for it here, then we're free to add extra fields on top. So we've got these view models that can be reused in various places, but it's very clunky to work with and incredibly hard to follow this. Remember, all we're doing in this code is loading a view model, filling up the fields, return to the screen, but we've drilled through a whole bunch of code and of unnecessary complexity just to get to this point. So the next thing I'm going to talk about is some other issues around the repository layer. Okay, so in order to talk about the repository layer, what I'm going to do is actually walk through the save operation now. So previously we've looked at, I want to edit a page, let's get that page back. Let's take a look at what happens when you save. So you get a post now, a HTTP post coming to this edit method, and we're passing back that view model, edit item view model, and that eventually comes through to this item logic.update function. So let's take a look at that.
Now looking at the update command inside the item logic class, and you see that takes in our entity view model to be saved. In this case, now it's been cast to item details, which is a higher level version of that class. And the first chunk of code, all this stuff, is just validation. So let's move forward from there. And you can see we do a couple of things really. We take this item and we feed it into the item repository, compare and update. One thing that's slightly odd is we have this code here called attach badge notification. If we take a look at that, what we've got are these event handlers, little bits of code to run on certain events. And what's actually happening is the repositories themselves have events that get fired from the repository up to the item loader again. So as I'm saving, there's logic work being done inside the repositories that can then fire events to fire badge warnings. So what this really means is repositories aren't doing what repositories usually do, which is just save objects. There's a whole bunch of logic being run by the repositories. And I think that's a big code smell, because the whole point of using well-known, well-defined names like repository is that when you say this is the repository for something, you're kind of specifying how you expect it to behave. You expect it to work like other repositories work. But what's happened here is there's been these layers put in place, a logic layer and a repository layer, and then the repository layer is filled with half of the logic that should probably be in the logic layer. And that makes it extremely hard to work with, because you have to go through and read all the layers in order to understand what's happening, not just the layers you expect. And it takes a long time to discover that that's what you need to do. So that's definitely something I find problematic. Okay, so continuing our walkthrough, we're now looking at the item logic class inside the update method, and here's the line where we actually call the repository to go ahead and finally save our updated items. So by this point, we've taken a view model, we've copied the items from the view model into a new copy of the item, and then we feed that into this compare and update function in the repository. And once again, because there's so much logic in the repository here isn't just doing a take this data and save it. It's take this data, apply all this other logic, and then save it. And because of that, where you'd normally expect to see some pretty simple give it to entity framework and let entity framework save it, we're seeing a whole lot of logic. Because what we do is we take this entry that we've just been fed, we load a new entry to compare it to, and then we run this custom functionality on top of entity framework, which is valid and dirty, which digs around and makes sure and works out, performs extra server-side validation, and then works out if it needs to be saved to changed. Then we've got this copy updatables, which manually copies fields from what we're saving to the actual final entity, and finally we're calling update on that entity. So there's a whole lot of custom functionality going in here. And if I drill through to the copy updatables for the item repository, you can see that for every field we're having to manually touch it a number of times and actually go digging through. So we're manually touching all these fields for the isValid and dirty function. We're then manually copying all these fields for the copy updatables. Here we go. We're running through and copying all these fields between two versions of a persistent entity. So a lot of this stuff is this stuff you don't need to write if you use the entity framework properly. And I think the only reason we're having to do this by hand is for the way change tracking has been implemented, and because of all the logic that's kicking around inside this application. But there's one more thing to show you, which I think is actually the biggest mistake in the entire repository system as it stands, and that's the concept of statefulness inside the repositories. So if we look at the top of the item repository class, you see we've got all these private fields, such as the last priority, last require approval, only priority is dirty. And what happens is, while all this processing is going, you saw that we actually call a number of methods. We call the isDirty, we call the copy updatables, and then we call update. Well, during those operations, some of these stateful fields are being set. So which means that the order in which you call the methods on the item repository matter, and it also means that you can't use more than one object at a time with this repository class.
So by the standard design, repository classes should be stateless. You should be able to take a repository class and feed multiple instances of that class into the item and have them saved. In this case, if you don't call the methods in the right order with an entity to be persisted, it won't work. And there's actually a huge danger of, if you actually try and push two records through the same repository in the same requests, you can have all kinds of weird state errors, because calling a method on the previous one would set some of these fields and then have it out of sync with the next field, next entity you're passing through. So as it stands, my recommendation with this code is do not try and work on two items inside a single request, because all this stateful data makes that very dangerous and very hard to find. And because this is not implementing the repository pattern as it was intended, anyone using this can say, oh look, it's using repositories, I'll go ahead and use repositories, and then not know that there's all this underlying complexity and logic behind the scenes. So the only way to work on this is to go and dig all the way through all these layers and read all the code. Now, as you can see, we're talking about a very simple feature here, and I've been speaking for 20 minutes just showing you some of the code involved in making that happen. So in conclusion, I think that this code base has some issues. There's code that looks like it follows a pattern, but when you dig into it, it doesn't follow the pattern. There's code that's far too complicated, far more complicated than it needs to be. There's needless use of inheritance that doesn't have to be there. There's logic classes that are far too complicated because they have to have generic methods in order to support that inheritance model. And there's code that looks like it follows a pattern, but when you dig into it, it doesn't. And the most dangerous of those patterns are having stateful methods. There's stateful methods that are logic classes, and there's stateful methods that are repository classes inside repository classes, and that means you're going to be really careful how you use them. And there could be all kinds of bugs from not understanding this and using them in the wrong order. So that gives you an overview of some of the problems I think we need to try and clean up when we're working with SugarLearning, and also trying to explain why people struggle to make progress in SugarLearning. I've seen people struggle to implement simple changes just because the amount of code involved in doing these simple operations is currently far too much and far too complicated. So you've been listening to me, I'm Brendan. That was a review of some of the code in SugarLearning and highlighting some of my problems. What I will follow up with very soon is some more videos on what my suggested fixes to this problem is. Thank you for listening and watching.